High in the eastern Himalayas, where mountains rise like walls of stone and rivers cut through the earth with unstoppable force, China is preparing to build what may become the most powerful and challenging hydropower project ever attempted. This is not a dam placed in a wide valley or a calm river basin. It is a project located in one of the most geologically active, remote, and hostile environments on the planet. The river is the Yarlung Tsangpo, a Himalayan giant that plunges through one of the deepest gorges on Earth before flowing south into India and Bangladesh. At one point, the river drops thousands of meters in a short distance, releasing an amount of energy that engineers describe as almost unmatched anywhere on the planet. Here, China plans to harness that energy through the Medog Hydropower Station. This is the story of how China is attempting to build a hydropower project at the edge of what engineering can handle. The river that defies control, the Yarlung Tsangpo, is unlike most rivers used for hydropower. Originating from glaciers on the Tibetan Plateau, it flows eastward before making a dramatic U-shaped turn around the Namcha Barwa mountain, plunging into a gorge deeper than the Grand Canyon. In this section alone, the river drops more than 2,000 meters in elevation over a relatively short distance. This drop represents enormous kinetic energy. Energy that, if captured, could generate more electricity than many entire countries. But this same energy makes the river dangerous. The current is violent. Seasonal glacial melt causes extreme fluctuations. Landslides, earthquakes, and sudden floods are constant threats. This is not a river that can be tamed easily. Why Medog matters? China's demand for electricity continues to grow, even as the country transitions away from fossil fuels. Hydropower remains one of its most reliable sources of renewable energy, providing stable baseload power that solar and wind cannot always guarantee. The Medog project is designed to be a run-of-the-river hydropower system, meaning it relies on the natural flow and drop of the river rather than a massive reservoir. This approach reduces flooding upstream, but demands extraordinary precision in engineering. If completed, Medog could generate tens of gigawatts of power, potentially surpassing even the Three Gorges Dam in output. This would make it one of the most significant energy projects in human history. One of the most difficult locations on Earth, Medog County was one of the last regions in China to gain year-round road access. For decades, it was accessible only by foot or limited air transport. Dense forests, steep terrain, heavy rainfall, and frequent landslides isolate the area for months at a time. Before construction could even be discussed, basic infrastructure had to be built. Roads were carved into mountainsides. Bridges were suspended across deep ravines. Power lines and communication systems were installed just to support survey teams. This phase alone took years. In Medog, reaching the site is an engineering project by itself. Earthquakes and geological risk. The Himalayas are one of the most seismically active regions on Earth. The Indian tectonic plate continues to collide with the Eurasian plate, generating constant geological stress. Any major structure in this region must be designed to survive powerful earthquakes, landslides, and rock deformation over time. Engineers conducted extensive seismic surveys, deep borehole drilling, and rock stress analysis. Entire tunnel alignments were adjusted to avoid fault zones. Structural designs include flexible components capable of absorbing movement without catastrophic failure. This is engineering built for a moving Earth. The design diverting a mountain river. Instead of blocking the river with a massive dam wall, the Medog project relies on river diversion tunnels. Water is diverted from the river through long tunnels drilled deep into the mountains. As the water travels through these tunnels, it drops rapidly in elevation before reaching underground powerhouses where massive turbines convert kinetic energy into electricity. After passing through the turbines, the water is returned to the river downstream. This design minimizes surface disruption, but requires some of the longest and deepest hydropower tunnels ever constructed. Digging through the Himalayas. Tunneling in Medog is among the most dangerous construction tasks in the world. Rock conditions change unpredictably. Hard granite can suddenly give way to fractured zones filled with pressurized water. Tunnel boring machines must adapt constantly, while crews remain on high alert for collapses. To manage these risks, China is using advanced tunnel boring machines equipped with real-time monitoring systems. Sensors detect changes in pressure, vibration, and rock strength, allowing operators to respond instantly. In some sections, excavation proceeds only meters per day, not because of machine limits, but because safety demands caution. The underground powerhouses. Unlike traditional dams where turbines are visible, Medog's powerhouses are buried deep inside mountains. These underground caverns are massive, tall enough to hold multi-story buildings, yet hidden entirely from the surface. They house enormous turbines designed to handle extreme water pressure and flow velocity. Constructing these caverns requires precise blasting, reinforcement with rock bolts and concrete liners, and continuous monitoring for deformation. The mountain itself becomes part of the structure. Managing water at extreme pressure. As water descends thousands of meters through tunnels, pressure builds rapidly. Pipes, valves, and turbines must withstand forces far greater than those in conventional hydropower plants. Engineers use high-strength steel penstocks, pressure relief systems, and redundant safety valves to prevent catastrophic failure. Every component is designed with wide safety margins. A single failure could release energy equivalent to an explosion. This is hydropower at extreme scale. Environmental and regional impact. The Yarlung Tsangpo eventually becomes the Brahmaputra River, flowing into India and Bangladesh. Any major project on this river raises regional concerns. China emphasizes that Medog's run-of-the-river design minimizes water storage and downstream impact. Continuous flow is maintained, reducing the risk of large-scale disruption. Environmental monitoring systems track river flow, sediment movement, and ecosystem health. Adjustments are made to ensure stability throughout the system. Still, the project remains closely watched beyond China's borders. Why this project is unlike any other. Medog combines every major challenge engineers can face: extreme terrain, extreme geology, extreme water energy, extreme isolation. Few projects attempt to solve all of these at once. Medog is not just about generating electricity. It is about proving that infrastructure can be built where nature offers almost no margin for error. Engineering at the edge of possibility. Hydropower has existed for over a century, but Medog pushes it into new territory. Every decision balances energy demand, environmental risk, geological uncertainty, and regional stability. Nothing is simple, nothing is guaranteed. Progress here is measured not in speed, but in survival. When Medog comes online, if completed as planned, Medog will supply massive amounts of clean energy, reducing reliance on fossil fuels and supporting China's long-term energy transition. It will stand as one of the most powerful examples of what modern engineering can achieve and how far humans are willing to go to harness nature responsibly. So now you've seen how China is attempting to build the Medog Hydropower Station, a project set deep in the Himalayas where rivers fall faster than anywhere else on Earth and engineering operates at the edge of possibility. Do you believe projects like this represent progress, or do they push nature too far? Let me know your thoughts, and thank you for joining this series on the world's most ambitious mega projects.